mechanical sensor data. In reality, most of the data that we were working with was record data regarding problematic incidents that happened on fleet management ships. So there's two main types of incidents. There's near misses, which were almost problematic outcomes, and incidents themselves, which resulted in more than $10,000 in damage. So we were working with data related to those, text fields that were filled out by people that were on the ships when those incidents occurred, as well as data about where it occurred, the data that occurred, and other metadata like that. And we were mostly working within Amazon's SageMaker platform, which basically was just Jupyter notebooks, but provided kind of an interesting insulated way to do work that was, I think, new to most of us.
So one of the first things that we did was conduct a time series analysis and a cross-sectional analysis of near misses and incidents by vessel type, just to kind of look at the overall trends of the data, because Fleet was very interested in, hey, is this one group reporting way too many near misses or incidents? It turned out that near misses at the beginning of the data set would have a lot of fluctuations, and we think that this was due to an adoption period. But towards the end of the data set, once things were more regular, once you normalize it by number of ships, it was pretty consistent. And we actually found out that this was because near misses are expected to be reported 8 per month, as Nico will talk about later. These analyses in and of themselves didn't particularly identify any huge trends, but they're very helpful to Fleet's operations.
So next, as Ahana mentioned, we did have manually entered text reports. To do an analysis on them and to extract some useful information from them, we conducted a topic modeling exercise on the same. Our basic objective of this exercise was to see if there are key themes under each category of the incidents that were happening on the ship, and if some particular theme dominated over the other. So under the mechanical category of incidents, we did see that year over year, engine and pollution related issues dominated. And similarly, in the category of injury related issues, falls were the most dominant theme. Cuts also showed an increasing trend and were a close second when it came to 2020. Please note, to plot the graph for 2020, since the year is not complete, we actually estimated the number of incidents that could happen using the number of quarterly incidents that have already happened per category.
So after we learned about the fleet's 8 near miss per month quota for each ship, we tried to figure out, whether ships were generally adhering to this policy or were a little under it. And what we saw suggested that generally ships are adhering to it. 472 had 0, and that's out of about 630 ships total. And so after we found out about that, we became curious as to whether the entries for these near misses were actually distinctive and unique, or whether they were just potentially reusing old entries. And we actually found that generally they weren't using old entries, but at least every ship had one entry with descriptions that were exactly like an older entry, whether that was from literally a day ago or 2 to 3 years. And this would max out at around 35% of entries for a given ship, which is definitely something that we wanted to continue to look into.
Yeah, and so just ending on a positive note, I think that this summer, this time period was around the first time that fleet management has ever hired like a data scientist. So the final form of our deliverable was a pretty big report that was read by a lot of the upper level management at the company. And yesterday we had a meeting with the chief technology officer, who communicated that the insights were very valuable and that they were kind of rethinking their approach to data and trying to figure out where they're going to go in the future. And so we hoped that a lot of the things that we were looking at this summer would help them kind of guide themselves towards a more data-friendly future. Thank you.
So, thank you all very much. This has been 10 weeks of really good work. What you just said at the end, I think resonates with a lot of experience, where I once saw a really good presentation called First Data Scientist Through the Door, where it's a very interesting experience when you have a company that has not hired data scientists before and you're the first one. And I think you will get exactly what you got here. And so I think you've helped them map out what that might look like in the future. Folks, go ahead, questions in the chat or unmute yourself either way.
Hey, this is Anil here. Yeah, so in talking to our chief technology officer yesterday, Shah Irani, he sort of said that the title of the project was a little bit sort of like North Star, like this is what we want to be shooting for. But that being said, I mean, nothing that you've presented here is predictive. Having looked at the data, what would you say Fleet could do that is predictive from what you've seen?
I mean, from the data that we had, the near misses just weren't significant enough to ship operations to make any predictions from. We graphed all the near misses and the incidents, and an example of near miss is stevedore found smoking on deck advised of ship's policy. So you could maybe make an argument that if a ship has a lot of near misses, maybe they have a lax policy, but we actually found that the more near misses that they reported, the less likely they were to have a extremely high number of incidents. There was no direct correlation there, but they just didn't have any outliers. So if you really wanted to make predictions, you would need more details about whether the people on board the ship are actually making their safety checks, whether like things are falling through the cracks, or whether these near misses are just being reported by the captain to meet the requirement. So we really didn't find any room for prediction in the data.
Just to add on to that really quickly, I think Jackson is talking about predicting future near misses or incidents. One thing that we did look into a little bit though was whether we could predict the categorization process for near misses, because I think right now they do that manually and it's a little slow and cumbersome. And we, in our report, we actually discussed briefly about the potential of using some kind of classification algorithm to predict the categories for the near misses based off the descriptions that the people on ship provide.
Yeah, just one comment on, as someone who's done some work with the Air Force on sort of actual predictive modeling of failures, it's the sensor data also in some sense isn't the holy grail, because it's amazing the difference between the controlled experiments you need to do for machine learning and what actually happens in the air. And so I think a lot of folks there at least are very, very sour on the benefit of that sort of thing. And so I think it's a gap. It's you can talk them to setting up really controlled experiments, and then people don't always trust them when they're actually deployed. So it's very new. Other questions? So I guess here's a prompting question I have. Of the technical tools you used here, is there anything you didn't know how to do before? And if so, how do you feel about it now?
Here, I can answer this one first because I think I may have known the least coming in. I'm a mechanical engineering major who just happens to have done a lot of Python coding for like data scripts. So coming into a digital environment in S3 and actually having to deal with the data structure and pulling them from different folders and actually having to care about runtime to some degree because we had like tens of thousands of records. That was really a learning curve. Nico had all these gorgeous pandas data frames. I was building dictionaries with keys for years and months. And it was just a really good example of how to code right. So there was a big learning curve there, at least personally.
Cool. I'll say the evolution of how to code right just gets farther and farther away from me as I go. So Ben Williams asked, how did your approach to solving this change from when you first started to this final product?
I think one thing that's important to mention is that there's like a lot of back and forth between us and one of the data scientists at Fleet. So when the program started, we completely expected to be doing something different. Then we got different guidance, and then we kind of went about our way thinking what we were doing was right and kind of doing our own explorations. And then halfway through the program, that data scientist was like, we need some kind of report that's readable by executives. So then we had to shift our entire focus to working on that and doing things that were a little bit more low level, I guess, or more exploratory. So I think it was just taking feedback from the company itself and then doing what they wanted and communicating more amongst ourselves too.
That's exactly the first data scientist through the door experience. Other questions? Is that someone asking? No, that's just someone. Has this affected what you want to do next in any way?
I think in terms of, I can take that question. In terms of what we do next for, what can be done next for this particular project, since the data scientist at Fleet already said that the results were put to some kind of use, as the company had not really used data science or anything remotely close to machine learning for their operations and regular use. So I think this was a pretty good start, and after this it is I think we need to or whoever works on the project needs to actually build this into a cohesive form of a dashboard, because to actually facilitate the use and make the results a little more comprehensive, because right now I think it's more reports than a tool that could be used.
Makes sense.
Mm-hmm.
I actually meant more personally as well. Like for the others, like has this affected like your trajectory and what you want to do career-wise or school-wise or things like that as well?
Okay. Personally, I was always interested in the space of manufacturing and more about like so I come with experience in the domain, data science experience in the domain of automotive manufacturing. So that is why when I volunteered to be a part of this project, I wanted to be a part of this project because it was a segue and yet related to that particular industry. So I think given that I personally learned that the automotive industry uses data science much more than the shipping and the fleet industry. So I would definitely want to explore the possibilities here, given they're very new to this. So obviously, there's much more to do and much more to learn. So I think I'd definitely want to see how the fleet industry can use data science here.
Cool. So we actually have a question in the chat. Jihao asks, for the time series analysis, do you think there's a seasonal variation pattern?
Yeah, we made some graphs that had for each individual year, graphing the near misses and incidents by month. And you would usually see a small spike around August and July. So somewhere in the Northern Hemisphere, but we didn't actually have locational data for the ships. So they could have been in the Southern Hemisphere in winter months. I think that it may have just been a more active time for the shipping industry and just had more ships that were out and about. But I guess it's also possible that weather conditions would have been different. But we didn't really have access to enough data to say why that trend occurred. We could just report to fleet that it did.
That makes sense. Yeah, I'll say in my general experience with a lot of the early data science cycle, you notice a potential pattern, you point out you don't have enough data to see it, and at least you create the motivation for them to go get that data. And so that's useful work, even if you can't make a complete story.
Yeah, I mean, I guess from the conversations that we had with their data scientist and their CTO even yesterday, it is almost surprising. You know, they collect all this information in these text records, and then it sounds like they go into previously had just gone into a black hole. So you know, there's definitely some low hanging fruit in terms of business and operational insights. In once they were able to clean up the data and parse it in some meaningful way, you know, even producing these graphs that you see here was a ton of effort and something that Fleet hadn't even seen before, which might be surprising to a lot of us. But I think that sort of speaks to where the shipping industry is in terms of making use of the records that they have. So, I mean, that seems like a big takeaway right there, is just providing value through data, without actually even needing any complicated tools or complicated statistical tools. Really, just being able to do the parsing.
Yeah, I mean, I'll say that I am no longer in any way shocked when I see a very radical disconnect between folks who collect the data, folks who later want to analyze the data, folks who want to tell stories about the data that's collected without ever having actually looked at it. I'd say this is pretty endemic across City of Durham data, across corporate data, across almost anything that isn't canned machine learning exercises. I'll let you in on the secret agenda of programs like this, is that we want people early on talking to each other and getting to know each other, who collect data, analyze data, visualize data, so that this problem gets fixed later. But this is, I mean, there's nothing strange about the situation at Fleet. This is how most data is collected. You sort of collect it, you're told you're collecting it, you put it somewhere. The idea that people who are going to analyze it would have influence on how it's collected is sort of how it should be, but is often not. Other folks have questions, and unmute yourself or in the chat. Well, let me ask this question. Suppose you got to design a shipping company from scratch, and suppose you actually wanted to do predictive modeling of mechanical failures. So I'm waving a magic wand here. How would you do it?
Sensor data to start, but then I would also, I think a lot of these incidents could be prevented by a little more technologically advanced oversight of the crew. Most of these were crew mistakes that caused these dramatic incidents, such as when they're cleaning the carbon dioxide room, they would like leave a valve open or accidentally shut the door.
Yep.
So the biggest boon to operations would be some way to automate records of completion of their daily tasks. So if they like were able to make voice logs or some other way for the data to be collected more about what the individuals on the ship do, then once it becomes a problem and management has to see it, then I think you would see a huge increase in some sort of predictive power. Even if it's less mechanical failures, you could find a lot more part failures and stop a lot more dangerous incidents.
Mm-hmm. That's awesome.
I mean, to that point, it's almost like just, you know, you still get text data out, but you're getting a much finer grain resolution in terms of time, right? Instead of a near miss where, you know, you just have sort of the end result of like, this thing happened, you have a record of all the steps along the way. So it kind of gives you a little more resolution, and then you can potentially do some more prediction based on, oh, this crew constantly misses this particular step and that causes these problems.
Mm-hmm. Makes sense. Any other questions? I want to flag the next session starting at 11. So in a couple of minutes, we'll switch out which group's presenting, and people can go to different rooms or stay here.
Yeah, I'll ask, I mean, talking about text data, and since y'all were expecting sensor data and received text data, what were the sort of pre-processing and I would say caveats that you need to think about when you're dealing with text data versus something numerical? I mean, I think of these things in terms of variance and bias. So like, what did you see as like the equivalent in text data?
Because I mean, even in text data, because they were manually entered reports and descriptions of an incident, I don't think there was a very defined standard according to which these reports were written. So some of them were very ambiguous. In terms of pre-processing, we did follow the steps that we all do in any kind of text analytics project, which is removing the stop words and lemmatization and completing converting short forms to actual words. And so we did all that, but even after that, the kind of information that comes from each of these descriptions were not very strong, because again, some of the descriptions were written as guard fell asleep. Now that doesn't really explain what really happened, as unless you look at it in conjunction of the other records, as in what kind of category that incident was, and where in the ship it happened. So those kind of caveats were there, and obviously that is why just text analytics on this particular data would not reveal something that we don't already know. But yeah, I think that is one major caveat that I can think of. Did I answer the question though? Is that what you meant?
Yeah. I mean,
Mhm.
the question largely was around, if you're expecting numerical data and that's sort of like what you're gearing up to do, and then you receive text data. It's like how do you like shift your thinking and shift some of the pre-processing steps that you're talking about doing, and like and how do you come up with like a sort of qualitative signal to noise ratio, or another thing you see in text data is um, it's not a sensor that's sampling at some fixed rate, right? You've got people compiling these reports, and there's some element of underreporting, over-reporting, or
Mhm.
but yeah, I think you did answer the question that there are a lot of nuances that come with text data that you don't necessarily have with fixed sampled sensor data.
Mhm.